So you notice, these are the results which are obtained. So what I did, I have gone to the folder where the xilinx ISC is generated those files and all. In model sim, I have clicked that command do space build.do. Then I got these results, isn't it? Simulation would take easily, I should say some 4 to 5 minutes because you are running up to 400 microseconds. Okay, so you have to wait until this comes. So this is a screen which you get output results, but you should be careful because once you open only this portion. You have to scroll down to see this one. Okay, so you can notice the signals is done signal and early done signal. See, this is actually one second. This is actually the early done signal, and this is your done signal. Okay, so 64 point FFT you are computing, and input signal is this one, CAS. Okay, and you can notice the frequency which you are generating is 100 kilohertz and the sampling rate is 1 megahertz. So in a cycle you will have 10 samples. Okay, you can notice if you count there will be 10 samples in one cycle of the CAS. Okay, so this is the FFT output. Okay, so what I have done in that coding you have, that video you have seen, we are computing the absolute part of xk of real and absolute part of xk of imaginary, then we are summing up both. Of course, that is not the correct way to compute the magnitude. Magnitude is equal to under root of real square imaginary square, but however approximately we want to see. So we have computed absolute of real and imaginary, added them, and that is plotted here in analog form. Okay, if you don't know how to plot something in analog form, you contact you discuss with my colleague, she will explain it. Okay, so any digital bus you can plot as analog. You right click and go to an option called format, choose analog. Okay, then it will plot as analog plot. Even the CAS also has come like analog plot only like this. Otherwise any digital bus will come like this only as a bus. This is a bus notation. Okay, this is analog plotting. So analog plotting is required to see visually that FFT is coming like FFT peak. See now, so what is happening here is, from here to here it is one FFT computation. From here to here again one FFT computation. So all these graphs, this one, what you are seeing is each one is one FFT. Got the point? So only one FFT I want to actually you to observe closely. So I will zoom into this FFT window. You know that FFT graph will be symmetric. You got the point? So at what index it is reaching maximum, when you want to see, choose this mouse cursor, click onto the screen where you have the maximum. Then you will notice at what index it is coming. What index it is coming? 6. This is xk index which I am plotting. So at xk index 6, the magnitude of this FFT output is reaching the peak. So 6th index is peak. You got the point? So this FFT will be symmetrical, right? So you
indicating only one cycle here, right? Index value is indicating only in the first FFT cycle. Index value is
no index. Mana baba, it is only just because the printing is not actually visible. That's why it is coming like that. Thoda sa bada kar do, it will be visible. You are talking that the xk index is not visible, right? It's only just in that printing it is not visible. That's why it has not shown. Now you see, okay, it is initially because initially it will take time for taking the samples. Once the output starts coming, then xk index will have value. See, now xk index is 0 at see now you see these all values are visible. Xk index will be coming continuously. The output also will be coming in streaming output only. 0, 1, 2, 3, 4 like that up to 63 it will come. Again it will start from 0. You see, it has gone to, acha, see FFT because it is symmetrical, whatever comes at 6 it also comes at 58. Isn't it? For a real spectrum it will be symmetrical, right? See, again it is coming at 6. This is the next cycle. See, 63 and 0. This is the next FFT computation. That's why you see early done and done. So done is over here means what? Whatever the next is starting is basically the next one. Got it? So the FFT is coming, continuously coming, because you continuously fed console, continuously it will come. Like this. Got it? But in any cycle you observe it will be 6 only. But if you change the frequency it will change here. Okay? So can you tell me now it is which type of streaming we are talking of? I mean which type of overlapping? We discussed it in the last video that DAFM video, that overlapping options. What you are talking, which overlapping this is? 0% overlapping? 50% overlapping? 100% overlapping? What type of overlapping this is?
The 0% overlap.
100, yeah, right, you are right, sorry, you are right, 0% overlapping, because you are taking first 64, computing FFT, then complete first 64 are over, the next 64 you are taking, so it's a 0% overlap we are computing for, okay. The 8-point FFT, what we will do on this one, and we will show that will be I think for 100% overlapping, if I remember properly, okay. 8-point FFT also with our own coding we are going to show that, right, that will be for 100% overlapping. This right now we are showing for the 0% overlapping. If you want to do it this one, for 100% overlapping, what you have to do, you take one sample, all the previous 63 samples you have to run this core again, okay. This need to be very faster, okay. 63 point is a very big number, right, so we can't easily perform 100-point FFT. I doubt whether it will work or not, that high frequency, got it. But 8-point is smaller, right, okay, that's why we could perform 100 points FFT over there, okay. We want to demonstrate both the cases, 0-point FFT and 100-point FFT. Now in this case, can you talk time resolution and frequency resolution? In this context, can you talk time resolution and frequency resolution? Okay, before doing time and frequency resolution, let us justify the number why at 6 it is correct. No? We discussed these equations, okay. How do I justify that at 6 it is supposed to come the peak? That is important, okay. The parameters which right now we have set for simulation, sampling frequency is 1 megahertz. Input frequency is 0.1 megahertz. Achha, I didn't show you one thing. There is a test bench for the code. In the previous video which I was explaining that top module code explanation, I haven't explained the test bench. There is a test bench for the top module. The test bench is only generating the clock. That's why I skipped it. You will file one more file, tb_top module like that, okay. The test bench is what actually we are simulating. Got it? That would only have clock and reset generation. So that I skipped it simply. You can see the code that clock would be generating 1 megahertz. Reset is just reset pulse comes at the beginning, okay. So now we are already seen the equation. When you know the index, how to compute the frequency. If m is the index where you have the peak output, then frequency is this one, okay. Now we need to perform the reverse. We know the frequency of the input, now we want to compute at what index it is supposed to come. If we substitute frequency is equal to 0.1 megahertz, n is equal to 64, fs is actually 1 megahertz, then it would come 6.4, okay. 6.4 means 6, because there can't be a fraction index. At 6 you are supposed to have the peak, and you are getting at 6 peak. You got the point. You can change the DDS score to write another frequency and you can run it. What I will do in the next version of the code, got it, I will change, after one cycle I will change that, I will switch to a different frequency, okay. Then you will see in one cycle one index will come high, in next cycle another index will come high. That we are able to prove that immediately when the input changes, the index is changing, isn't it? Right now it is only for one frequency. I will change the code little bit. DDS I will generate 2 channels, okay, and in one channel I will generate one frequency, second channel then second frequency. So I will feed for some time first channel, second time actually second channel. Then you will see results both coming like that. Okay. So is everything is clear? So what I did actually, I have just zoomed into one cycle, then I have taken the screenshot and I have kept in a Word file in your folder. This you can put in your document, copy paste. This is nothing but one cycle zoomed, and actually I have kept the cursor here to show that at 6 it is coming. You see here, at 6 it is coming. Clear?